Hello students. In the last class, we learned about the basic components and working principles of aircraft engines. Today, let us learn how to distinguish the basic types of aircraft engines. Aviation gas turbine engines can be divided into two categories according to their composition and working principles. One is the direct reaction propulsion system, and the other is the indirect reaction propulsion system. A direct reaction propulsion system refers to an engine that can directly use airflow acceleration to generate thrust, which includes turbojet engines, turbofan engines, etc. An indirect reaction propulsion system refers to an engine that first converts the kinetic energy and pressure energy of the airflow into rotational mechanical energy, and then drives propellers, rotors, and other components to generate thrust, including turboprop engines, turboshaft engines, etc. Next, I will introduce a very important concept to the students, the gas generator. The gas generator is a system composed of three components: the compressor, the combustion chamber, and the turbine. So, what is the role of the gas generator? First, the gas generator completes the work of the engine to convert thermal energy into mechanical energy. Second, different types of engines are formed by different distributions of the mechanical energy obtained by the gas generator. Third, the propeller of the turboprop engine, the fan of the turbofan engine, and the driving force of the rotor of the turboshaft engine all come from the gas generator. It can be seen that gas generators with different components form different types of engines. Next, let us learn the basic types of aircraft engines one by one. First, let us learn about turbojet engines. As shown in the figure, turbojet engines are composed of an air intake, a compressor, a combustion chamber, a turbine, and a tail nozzle. That is, the air intake and tail nozzle components are added to the gas generator. The turbojet engine relies on the turbine outlet gas to expand and accelerate directly in the nozzle, so that the pressure energy of the gas is converted into the kinetic energy of high-speed ejection to generate a reaction force, pushing the aircraft forward. So its thrust comes from the nozzle, and it is generally used in fighters and bombers. Next, we will learn about turbofan engines. Turbofan engines are divided into high bypass ratio turbofan engines and low bypass ratio turbofan engines according to different bypass ratios. Their structures are composed of an air inlet, a compressor, a combustion chamber, a turbine, a tail nozzle, and a fan. That is, an air inlet, a fan, and a tail nozzle are added on the basis of a gas generator. For a high bypass ratio turbofan engine, the gas expands and works in the low-pressure turbine to drive the outer bypass fan, increase the speed of the outer bypass airflow, and generate most of the thrust. The remaining available energy continues to expand in the nozzle to accelerate and generate a small part of the thrust, which is generally used in civil airliners or transport aircraft. For a low bypass ratio turbofan engine, most of its thrust is still generated in the nozzle, and only a small part of the thrust is generated in the outer bypass, which is generally used in fighter jets. The two types of engines we have learned above both use the expansion acceleration of airflow and the reaction force generated according to Newton's third law as thrust, so they belong to direct reaction propulsion systems. Now let us learn about turboprop engines and turboshaft engines. The turboprop engine consists of an air inlet, a compressor, a combustion chamber, a turbine, an exhaust device, a speed reducer, and a propeller. That is, an air inlet, an exhaust device, a speed reducer, and a propeller are added to the gas generator. The turboprop engine converts most of the available energy in the gas into shaft work to drive the speed reducer and propeller to generate pulling force. The remaining small amount of available energy in the gas is converted into kinetic energy of the airflow in the nozzle to directly generate thrust. It is generally used in regional airliners and transport aircraft. Finally, we learn about turboshaft engines. Turboshaft engines are composed of air inlet compressor, combustion chamber, turbine, exhaust device, reducer, and rotor. That is, air inlet, exhaust device, reducer, and rotor are added on the basis of gas generator. In turboshaft engines, almost all the available energy contained in the gas at the outlet of the gas generator is absorbed by the power turbine, driving the rotor of the helicopter and generating pulling force. The gas flowing out of the nozzle hardly generates thrust. Turboshaft engines are generally used in helicopters. Through the study of these two types of engines, we can find that they both convert the pressure, energy, and kinetic energy of the airflow into rotational mechanical energy first, and then drive the reducer, propeller, or rotor to generate pulling force to drive the aircraft. Instead of using the reaction force directly generated by the airflow as thrust, they are called indirect reaction propulsion systems. Students, in this class, we have learned about the basic types of aircraft engines and the concepts and functions of gas generators. Through this course, students should learn to distinguish between direct reaction engines and indirect reaction engines, as well as what types of engines they are, their structural characteristics and uses. Thank you, everyone.